Trigonometry. Trigonometric identities. We're going to look at sine squared plus cos squared equals 1 and tangent is sine over cosine. So let's look at some useful trigonometric identities. Suppose we've got a right angle triangle with an angle theta and we label the sides h for the hypotenuse, a for the adjacent side and o for the opposite side. Then we have the sine of theta is the opposite over hypotenuse, so o over h. Cosine of theta is a over h, the adjacent over the hypotenuse. And tangent of theta is o over a, the opposite over the adjacent. And so from Pythagoras' theorem we have o squared plus a squared equals h squared. And we can divide all the way through by h squared. Now that gives us o squared over h squared plus a squared over h squared equals h squared over h squared. And that can be written as o over h all squared plus a over h all squared equals 1. Now o over h is sine theta. So we've got sine theta squared plus cos theta all squared equals 1. And we write that sine squared theta plus cos squared theta is equal to 1. Now this is a very useful trigonometric identity. Now we also have sine theta over cosine theta is o over h divided by a over h, which we can write as a division sum. O over h divided by a over h. But if we're dividing fractions, we turn the second one upside down and we multiply. So sine theta over cosine theta is o over h times h over a. And we can cancel the h's. So it's equal to o over a, which is the tangent of theta. And this gives us the result that the sine of theta over the cosine of theta is equal to the tangent of theta. Let's have a look at an example of how we could use that. Suppose we're given the equation 5 sine theta equals 6 cos theta, and we're asked to find the value of tan theta, and then using that find the principal value of theta. Well, to solve it, we've got 5 sine theta equals 6 cos theta, and we can divide both sides by 5 cos theta. Then we can cancel the 5's, and we can cancel the cosine theta. And we're left with sine theta over cos theta is 6 over 5. In other words, the tangent of theta is 6 over 5, or the tangent of theta is 1.2. Now using a calculator we can work out the value of theta. Theta is the inverse tangent of 1.2 and the calculator gives us the value 50.194 degrees. This is the principal value. So we have theta is 50.2 degrees when rounded off to one decimal place. So we have the following results. Sine squared theta plus cos squared theta equals 1. And sine theta divided by cos theta is equal to tan theta. And we can use these results to solve equations involving trigonometry. So let's look at another example. Given the equation 8 sine theta equals 3 cos theta, write the equation in terms of tan theta and then solve the equation to find theta for theta lying between 0 and 180 degrees. Well, to solve this, we start with 8 sine theta equals 3 cos theta, and we divide both sides by 8 cos theta. Now when we've done that, we can cancel. The 8's cancel on the left-hand side, and the cos thetas cancel on the right-hand side. And that leaves us with sine theta over cos theta is 3 over 8, or we can write that tan theta equals 0.375. Now in part 2 we have tan theta equals 0.375, which means theta is the inverse tangent of 0.375, and we can work that out on a calculator. It comes to 20.556 degrees. So if we round that off to one decimal place, we've got theta is 20.6 degrees, and that's the only value between 0 and 180. If we look at example 3, given the equation 2 sine squared theta plus 3 cos theta equals 3. In the first part, write the equation in terms of cos theta. Well, to solve this, we start with 2 sine squared theta plus 3 cos theta is equal to 3. Now, because sine squared theta plus cos squared theta equals 1, we have sine squared theta equals 1 minus cos squared theta. So we can replace the sine squared theta with 1 minus cos squared theta. And if we expand the brackets, that gives us 2 minus 2 cos squared theta plus 3 cos theta equals 3. If we subtract 3 from both sides and rearrange, we've got minus 2 cos squared theta plus 3 cos theta minus 1 equals 0. Now if we change the sign all the way through, or multiply by minus 1, that gives us 2 cos squared theta minus 3 cos theta plus 1 equals 0. Now in the second part, we're asked to solve the equation and to find theta for values between 0 and 180. Now we've got 2 cos squared theta plus 3 cos theta plus 1 equals 0, and this will factorise. It's a quadratic. So it factorises as 2 cos theta minus 1 into cos theta minus 1 equals 0. Now, if two things multiply to make 0, one of them must be 0, so one of the two brackets must be 0, which means 2 cos theta minus 1 is equal to 0, or cos theta minus 1 is equal to 0. So 2 cos theta equals 1, or cos theta equals 1. Now if 2 cos theta is 1, that means cos theta is a half. So theta is equal to the inverse cosine of a half, or theta is equal to the inverse cosine of 1. Now the inverse cosine of a half, or the inverse cosine of 0.5 is 60, and the inverse cosine of 1 is 0, and those are the only two values in the range 0 to 180 degrees. Remember, we've had in the past, if theta naught is the principal solution to the inverse sine of x, then the general solution is either theta equals theta naught plus n times 360 degrees, or theta is 180 minus theta naught plus n times 360 degrees. If theta naught is the principal solution to the inverse cosine of x, then the general solution is theta equals plus or minus theta naught plus n times 360 degrees. And if theta naught is the principal solution to the inverse tan of x, then the general solution is theta equals theta naught plus n times 180 degrees. Let's look at an example. Given the equation 6 cos squared theta equals sine theta plus 4, in part 1 put the equation in terms of sine theta. Well, to do this, we start with 6 cos squared theta equals sine theta plus 4, but we know sine squared theta plus cos squared theta equals 1, and so cos squared theta equals 1 minus sine squared theta. Now we can replace cos squared theta in the equation with 1 minus sine squared theta, and then we can expand the brackets, and this gives us 6 minus 6 sine squared theta equals sine theta plus 4. And if we subtract sine theta plus 4 from both sides, we end up with minus 6 sine squared theta minus sine theta plus 2 equals 0. So if we change the sign all the way through, we get 6 sine squared theta plus sine theta minus 2 equals 0. Now in the second part, we're asked to solve the equation for values of theta between 0 and 360 degrees. So starting with 6 sine squared theta plus sine theta minus 2 equals 0. That's a quadratic equation and we can factorise it. This gives us 2 sine theta minus 1 times 3 sine theta plus 2 equals 0. Now if two brackets multiplied together make 0, then one of the brackets must be 0. So either 2 sine theta equals 1 or 3 sine theta equals minus 2, which means sine theta is a half or sine theta is minus 2/3. Now we can take the inverse sine of both of those. So if we take the inverse sine of a half, the principal value is 30 degrees. And if we take the inverse sine of minus 2/3, the principal value is minus 41.8 degrees. Now if the principal value is 30 degrees, that means theta could also be 180 minus 30 degrees, which is 150 degrees. If the principal value is minus 41.8 degrees, then theta could equal 180 take away minus 41.8 degrees, which is 221.8 degrees, or theta could equal 360 take away 41.8 degrees, which is 318.2 degrees. So we have four possible solutions. Theta could equal 30 degrees, or it could equal 150 degrees, or it could equal 221.8 degrees, or it could equal 318.2 degrees. Now we can see this on the graph of y equals sine x. If we draw the graph and then draw a line horizontally across at y as a half, we see it crosses the curve at 30 degrees and it crosses the curve at 150 degrees. If we draw a line horizontally across from minus 2/3 on the y-axis, it crosses the curve at 21.8 degrees and again at 318.2 degrees. So we have the same solutions as before.